Hello everyone and welcome to my channel. My name is Ismail Ali and this is Capital Petroleum Academy channel. Beyond this solid rock, there's a puzzle says, where are fluids hiding? This is a core sample of limestone saturated with oil. When students just like me holding this core sample, they see just only solid mass with no visible porosity or any porous media, and this is leading to question how does oil come out of this sample. Let's see in close. Okay, I think it's close enough to see. There is no clear porosity, just only tiny pores. Okay. The reality of pores in reservoir rocks are not holes visible to the naked eye. They are microscopic voids, spaces located between rock grains. Okay. Also, we have another reservoir rocks that holds porosity, maybe permeability. I hope it's clear. This is also a reservoir rock, another sample of reservoir rock that contains or saturated with heavy oil. This course called dolomite. Okay, also holding heavy hydrocarbons. So let's make this more clear about porosity. Let's suppose that this is a pile of sandstone. Okay, think about this. Let's suppose that this is a pile of sandstone in a bottle. Okay, think it's clear enough to see. The sand looks solid, but there is air inside or between grains. In a reservoir, these grains have fused over time, leaving behind microscopic storage units called porosity. So in this sample, as a sandstone, maybe we cannot see easily the porosity and intermediate or also permeability medium. So we will define more about permeability. Hello again. I want to clarify something related to fluid distribution. Okay, many believe that the water, oil, and gas are arranged separately, in perfectly separated layer. Okay, the water at the bottom, oil in the middle, and the gas in the at the top. This is entirely or partially true in a macro level, but it is entirely wrong in macroscopic level, because no reservoir rock contains 100% of oil. The question is why we can't find that, or why do we see water in everywhere that exists, even in tiny pore spaces? This is because the water is the original fluid or the primary fluid that fill pore spaces in very beginning during sedimentation process. Then the hydrocarbons, as oil and gas were migrated from source rocks like shale, for example, then migrated to reservoir rock and attempting to displace water from same pore spaces. Okay. Again, why do we see water in these places or in everywhere? This is because of the effect of waterability. I mean, the connate water that we see, the water in every pore or tiny pore spaces. Okay. Also, according to effect of capillary pressure. Now, I want to clarify more. We have a sponge. Okay, this sponge is already saturated with water, and I will add water to this sponge again. Okay, as we see, we have a sponge saturated with water, as we see. Okay, and I will add pure, let's say, crude oil. Okay, as we see, I'm adding oil to this sponge. Now let's see together. Okay, what do we see here? Sponge saturated with water, and then I added an oil, okay, to this sponge. What do we see now? What we see is a portion of oil where they goes to the deep, okay, and others floats at the top. Okay, this is what's going on, or what happened exactly in the reservoir. Okay, in same pore we can, or even in tiny pore, we can find oil and water in the same pore spaces as a microscopic level.